Hello everyone. The topic is comparison of D-glucose concentration between terrace rice and lowland rice. The presenter is Yuki Otsubo, and the CO researchers are Ayama Yamazaki and Kenichi Goto. Thank you for your attention. In recent years, rice consumption has been declining in Japan, prompting a renewed appreciation for its value. Therefore, this study incorporates not only food science but also the perspective of developing teaching materials for STEAM education using familiar ingredients. By scientifically visualizing the sensory value of sweetness in terraced rice fields, we explore the potential for learning that bridges everyday life and science. The purpose of this study is to compare sugar production during soaking in terraced and lowland rice, to examine the role of endogenous enzyme activity in sweetness development, to link traditional agricultural practices with biochemical analysis, and additionally, present it as a STEAM learning model integrating science, technology, engineering, mathematics, and art. This study used Niigata prefecture-grown Kashi Hikari rice, flatland rice, P. terrace rice, T. prepared for 3 years from 2023 to 2025. This allowed simultaneous evaluation of the effects of cultivation environment and year. In this experiment, we conducted Experiment 1, measurement of D-glucose concentration. Experiment 2, measurement of alpha-glucosidase activity value. The method for measuring D-glucose concentration was as follows. First, rice was sorted by particle size using a sieve, 1 mm to 2.36 mm. An exact 20 grams was weighed and soaked in 24 ml of water. The soaking temperatures were 40 degrees Celsius and 60 degrees Celsius, respectively, with a total soaking time of 70 minutes. Every 10 minutes, 100 L of the soaking solution was collected using a micropipette. After mixing with the E-kit reagent, the absorbance was measured at 340 nm. The obtained measurements were recorded, and the D-glucose concentration was calculated. By controlling the immersion temperature at 40 degrees Celsius and 60 degrees Celsius, we incorporated an engineering perspective focused on condition setting and ensuring reproducibility. The experimental design itself is also a crucial element of STEAM. During rice soaking, starch is broken down by enzymes to produce glucose. This process is understood through the integration of multiple fields: science, enzyme reactions and biochemistry; technology, absorbance measurement; mathematics, concentration calculations and data analysis. D-glucose concentration was measured using the E-kit manufactured by JK International Co., Ltd. This assay is based on enzymatic reactions catalyzed by hexokinase, HK, and glucose 6-phosphate dehydrogenase, G6PDH. The principle behind this is an example of utilizing technology to visualize invisible phenomena as numerical values. From here on, I will explain the results obtained from the experiment. Flatland and terrace rice from the 2023, 2024, and 2025 harvests were soaked at 40 degrees C for 70 minutes. Samples of the soaking solution were collected every 10 minutes, for a total of 7 time points per trial, and each measurement was repeated 3 times. The mean D-glucose concentrations obtained are shown in Fig. 1. As a result, it became clear that sugar production is promoted by temperature increase. Flatland and terrace rice from the 2023, 2024, and 2025 harvests were soaked at 60 degrees Celsius for 70 minutes. Samples of the soaking solution were collected every 10 minutes, for a total of 7 time points per trial, and each measurement was repeated 3 times. The mean D-glucose concentrations obtained are shown in Fig. 2. Under both 40 degrees Celsius and 60 degrees Celsius conditions, D-glucose concentrations increased with reaction time. At 70 minutes, D-glucose concentrations at 60 degrees Celsius were higher in all samples than those at 40 degrees Celsius. D-glucose concentrations increased gradually in all samples, reaching a harvested in 2023, 23T, showed higher values than the other samples, with a marked increase observed after 50 minutes. Among the production years, sugar production tended to follow the order, 2023, 2024, 2025. Within the same production year, terraced rice, T, tended to exhibit higher D-glucose concentrations than lowland rice, P. Differences between cultivation conditions became more pronounced at 60 degrees Celsius, with terraced rice exhibiting consistently higher D-glucose production than lowland rice. The alpha-glucosidase activity value was performed as follows. First, rice grains were sieved using a mesh, 1 mm to 2.36 mm, and 20 grams was accurately weighed before being immersed in 24 ml of water. The soaking temperatures were 40 degrees Celsius and 60 degrees Celsius, respectively, with a total soaking time of 70 minutes. Every 10 minutes, 100 ml of the soaking solution was aspirated into a micropipette, mixed with the alpha-glucosidase activity measurement reagent, and the absorbance at 400 nm was measured. The measured values were recorded, and the alpha-glucosidase activity values were calculated. Alpha-glucosidase activity was measured in Experiment 2 using a saccharification enzyme activity fractionation assay kit, Kikkoman Biochemifaco, Ltd. The principle is that the substrate 4-nitrophenyl alpha-D-glucoside, PNPG, is hydrolyzed by alpha-glucosidase to produce p-nitrophenol, PNP. The reaction is stopped by the addition of sodium carbonate, and at the same time, PNP develops color under alkaline conditions. The enzyme activity is quantified by measuring the absorbance of the generated PNP at 400 nm. Statistical analysis was performed using two-way ANOVA with cultivation type, terraced versus lowland, and production year, 2023-2025, as fixed factors for each temperature condition. Post hoc comparisons were conducted using Tukey's HSD test, alpha equals 0.05. All data are presented as mean plus or minus standard deviation of 3 independent measurements. Lowland rice and terraced rice harvested in the 2023-2025 harvest years were soaked at 40 degrees Celsius for 70 minutes. Alpha-glucosidase activity was measured every 10 minutes, 7 time points, with 3 replicates, and the mean values are presented in Fig 3. Alpha-glucosidase activity increased gradually in all samples, reaching approximately 0.14-0.23 U/ml after 70 minutes at 40 degrees Celsius. Terraced rice, T, tended to exhibit higher alpha-glucosidase activity than lowland rice, P. Lowland rice and terraced rice harvested in the 2023-2025 harvest years were soaked at 60 degrees Celsius for 70 minutes. Alpha-glucosidase activity was measured every 10 minutes, 7 time points, with 3 replicates, and the mean values are presented in Fig 4. At 70 minutes, alpha-glucosidase activity at 60 degrees Celsius were higher in all samples than those at 40 degrees Celsius. Among the production years, terraced rice harvested in 2024 and 2025, 24T and 25T, showed relatively higher values. Rice harvested in 2023 tended to exhibit slightly lower alpha-glucose concentrations overall. For all production years, terraced rice, T, consistently exhibited higher alpha-glucosidase activity than lowland rice, P. The effects of both production year and cultivation condition became more pronounced at 60 degrees Celsius. This study investigated the effects of cultivation environment, flatland rice versus terraced paddy rice, production year, 2023-2025, and reaction temperature, 40 degrees Celsius and 60 degrees Celsius, on the saccharification characteristics of rice starch by analyzing time course changes in D-glucose and alpha-glucose concentrations. In addition to contributing to food science knowledge, the study also serves as a practical model for inquiry-based learning in STEAM education. Higher sugar concentrations were observed at 60 degrees Celsius than at 40 degrees Celsius under all conditions, demonstrating that elevated temperature enhances starch gelatinization and enzymatic activity. Sugar concentrations increased over time, with a rapid initial rise followed by a slower rate, reflecting enzyme kinetics and substrate limitation. Terraced paddy rice generally produced more sugar than flatland rice, particularly at 60 degrees Celsius, suggesting that environmental factors such as topography and climate influence grain properties. Differences among production years were also observed, with rice from 2025 showing suppressed saccharification, possibly due to high temperature effects during grain filling, linking the findings to climate change impacts. Additionally, D-glucose was identified as a more sensitive indicator of overall saccharification progress than alpha-glucose. Overall, this study integrates experimental design, measurement, and data analysis, demonstrating its value not only in food science but also as an interdisciplinary STEAM education model that promotes scientific thinking, quantitative reasoning, and awareness of environmental and societal issues. Future prospects. We consider the measurement of D-glucose concentration in rice and wheat to be an effective model linking chemical analysis with real-world food science. Students can investigate the effect of temperature on starch degradation and directly relate enzyme reactions, molecular structures, and quantitative data. This framework can be extended to compare rice varieties and processing conditions, promoting hypothesis formation and data-driven evaluation. Furthermore, incorporating advanced techniques, e.g., solid-state NMR, allows students to relate macroscopic measurements to molecular-level structures, providing learning that bridges to university-level studies. Overall, this approach supports inquiry-based learning and fosters interdisciplinary thinking spanning chemistry, biology, and materials science. The following are the references. Thank you for listening to my presentation.